Is it recording? I think it's recording. At least that little button says it is. All right. Okay, so the first one has to do with how variables are passed to methods, and they're passed by copy of value. And so if the argument is a primitive, then that means that anything that happens to that argument inside the method does not get passed back to the calling method. So that's an important thing to really get clear about. Again, if it's copy of the value. So when, well, and I realize that a lot of the, it's kind of a challenge to transit from writing stuff down from NetBeans. But in NetBeans we're just typing, and here we're just writing. NetBeans obviously helps you out with a lot of these things. But NetBeans wouldn't help you out with this unless you actually ran it. So what I want to do is actually, let's test that out. But again, when you look at this method receives 3 arguments. It takes the third one and sets it to the product of the first 2 and then returns. So inside the method, it works well, but outside the method, even though these variables have the same name, they are not the same variables, because these are the local variables to main, and these are the local variables to the method multiply. Okay, so what you should get is exactly the same thing. So the key was this last one. So is this going to be 3 or 1? And it's going to be 1. But you say, well, is that really the case? So let's test it out. All right, now I'll just, being a little lazy, then where the heck are you here? All right, so let's just sort of copy this method here. And let's copy the, move you over here to copy this and see what it prints. And as you can see, the second one, it only prints 1, not 3. And if it had written 3, then I would have to go and regrade a number of things, but it didn't. So, okay, so that's what's going on there. And that's an important thing to understand, and it's also important to understand how that works with object references. So with an object reference, if you were to do something similar, that is, reassign that object reference as an argument inside the method, then it wouldn't affect the object reference that you were calling from. However, if you invoked a method on that object reference inside the other method that changed some value of that object, then that would change, because that copy of the object reference does refer to the actual object. Okay, but this is, this is important to understand, mostly for understanding what happens when things don't go quite as you expect. So a lot of writing the code is invoking methods, many of which are provided by either some library or by Java itself. And so it's important to understand what does and doesn't get changed. So, and if you're writing something like this, then this seems like a reasonable thing to do if the task that you're setting is, here, I want a method that will take a couple of arguments and multiply them together and give me the result. Okay, so, and I think some of you may have kind of noted that a better design for this, I mean, essentially this method does nothing. So it's kind of a useless method. But if you wanted to really make it do something, instead of having the result as an argument, you would want to return it if you wanted to do that. So now obviously, there wouldn't be much point in a method like this, but again, for the purpose of the exam, I wanted something that was just very simple, easy to see. And when you're writing methods like that, then the choice is often like what input and output. So typically the input are going to be the arguments and the output is going to be the return. Or if you have a method that's just going to maybe modify or do something, then you don't have to have a return like a void. Okay, so the second one has to do with who can see what. Okay, so there are three types of variables. There are instance variables. So we have instance variables here. There are class variables or static variables, and we got two of them here. There are two types of methods. There are instance methods, like this. A constructor would be considered an instance method for this purpose. And then there are static or class methods, like cold reset here. So new current value and toString are instance methods. toString, of course, is overridden from object. But the question is, who can see what? And the rule is, or the way that, and it's not a law of nature. This is how Java decided it, but it's a reasonable one, if you think about it. Instance methods can see everything in terms of class and instance variables. So new current value can see all four of these variables, both the instance ones and the static ones. But a static method like cold reset can only see the static methods, not the instance method. Can only see the static variables, not the instance variables. Okay, so, and again, that's who can see what is an important thing to realize about this. So again, just to put a fine point on it, let's test that out. Let's create one of these. I'll just paste in should be able to paste in the code. A few things will give me red squigglies, but that's okay. Let's just write that for now. Okay, so the question is, who can see what? Now my claim is that new current value can see all three. Let's test that out. In fact, let's test it out by also doing the sets the value to the argument. So the current value equals new value. Now if it couldn't see it, you'd get a red squiggly. And then increment the value of current value. So number changes. So number changes, again, we could increment that. We have a static variable called 1 that's equal to 1. So let's, again, no red squiggly. So if it couldn't see it, then there'd be a red squiggly. And then, let's see, that was final. Just to put a point on it, we can Again, it can see the static variable 2. If it couldn't, it would get a red squiggly. However, let's look at cold reset. Can it do? Let's try to increment it by 2. Okay, we get a red squiggly, and it says non-static variable current value cannot be referenced from a static context, meaning a static method cannot reference an instance variable. However, it can. We can do the same thing with the you can see the static ones, not the instance ones. Important to understand. Okay, and then the toString would be, we could just return, just anything that had both of them. Just something like that. Okay, so that was the second one. So again, just when it comes to this, just understand who can see what. That's the main thing of that. Okay, so this was probably maybe a little trickier than I completely intended. But part of it is to just kind of follow the constructors. So we're instantiating one of these second class things. Okay, so second class extends first class, and so just following the constructor, we pass a string in, we get the string, we pass it to the superclass but the superclass constructor requires an int value as well, so we give it 42. Okay, so, and then this sets message to the message, sets the value to value. Okay, so everything is fine. Now we print that object. So what's going on here is that how does the virtual machine now find the method to call? So the object is a second class object, and so when you print something, it calls the toString. I think you all got that. But now the toString in second class had overridden the toString of the first class. So what happens is you get just the value, not all this other stuff. And how are we doing? Oh, okay, I have time to do all this. Okay, so just to, oops. Okay, there's that one. Let's make it a main class, put the main in there as well. Okay, oops. And okay, now, now notice that before I paste in the constructor, we get that thing about you should understand what's going on here as well. Again, I talked at this, but it's important to understand mostly a lot of these things are less about writing the code and more about debugging the code. When you, regardless of what language you're writing in, most of your time is spent debugging and not writing. Just like as you'll learn in writing your thesis, or if you've never written a long document before, most of the time in writing is editing and not the writing itself. Okay, so this is one of the head scratchers that you may get if you don't understand what's going on here. So, and what's going on is stuff under the hood, and it's not at all obvious, and the message is just really weird. But it bears repeating. What's going on is that because, first item, every class has a constructor in Java. And if you don't write one, it will write a zero argument one for you. The second piece is that every constructor, the first call is either to super or to this. So put the this aside. I'll talk about that when I finish going through the exam. But the first call is going to be to super, and if you don't put something in, Java will write in super for you. So what Java has done under the hood, without your having to write anything, is it first wrote a zero argument constructor because you didn't write one, and then it put in a call to super with zero arguments, but then it realized that because the super class required a string and an int, that call to super is invalid. Syntactically, it doesn't work. If you call a method that requires a string and an int and you call it with nothing, then Java will not let you get to first base. So again, and that's one of the differences between a compiled language and an interpreted language like Python or JavaScript. And the reason for this, and the reason this is actually a good thing, is that you don't want your program to be running and running and running and all of a sudden hit a syntax error. So a compiler will guarantee that at least you will have no syntax errors. It doesn't guarantee you'll be error-free. It'll guarantee that you have no syntax errors when you go to run it. Okay, where is your, oh, there you are. Okay, so here's our second class. It needs this. And see that now the constructor that calls the super with the message and the other is enough to make it go away. Say just having the constructor by itself is not, because I need the other. And now let's and now when we run it, all we get is 42. Because, why? Because the print line for the second class called the toString, and there it stopped. Because toString overrode the toString in the superclass. Okay, so this was about method overloading, overriding. Overloading is when you have the same method with a different signature. Overriding is when you write one with the same signature that's in the superclass. And when you call it, you call the one that's lowest in the hierarchy. Okay, now number 4, again I accepted anything that was reasonable, and I think the only points that were lost were cases where you didn't put anything in here. I mean, it's hard to grade something that's not there. I mean, just anything would have been fine. And most of you got that okay, but so that. Okay, so again here, this was about integer arithmetic, specifically integer division, which is different in Java than it is in other languages that kind of do some stuff for you. The problem here is that this division and the way that these things are computed is that you first compute the right side and then assign it to the left. So sum is an int at 102, count is an int at 52, 102 over 52 is 1 and change. But the integer division means it's going to just lop off the change. So what you get is just a 1. This was kind of a, okay, so what this question was about is about the scope of variables. The problem here is that the scope, what is the scope of the variable x? X only exists inside of this for loop. It doesn't, it's undefined outside of here. So this would actually, the output would be a syntax error. And then this was just a matter of, stepping through a do while loop. And I think most people kind of got this, but it was just stepping through. This is something that when you're writing something, when you're writing a piece of your program that's going to do something like this, it's important to step through and as I said, sort of be a scientist about it by forming a hypothesis ahead of time as to what it's going to produce. So in this particular case, remember the do while the do while always executes at least once. So starts out at 5, but then immediately gets decremented, and you print count, which is currently 0, and start. Then now count is 1, and then the condition is start is greater than 2. So start now is 4, that is greater than 2, so you go back and do it again. Then start goes to 3, count is now 1, now count is 2, start is 3 greater than 2, now start is 2, count is, and then count. Now finally start is 2, and then you print one last 2. I think some people forgot the last 2, but that was.
It shouldn't have printed out 2 though, right?
It would, because it's 3 when it goes into the loop, and then it becomes 2.
Yeah. So.
Here. 2, and the very last line is 2.
Yeah. So well, let's test it out here.
I believe you.
Yes, 0, 4, 1, 3, 2, 2, and then the one last 2 is just because there was one last one. But the principle is that whenever you can, have kind of do it by hand to make sure that it's doing it right, at least for a small test case. Typically, the loops that I write, for example, in some of this inventory modeling and simulation that I've been working with, I mean, there will sometimes I'll have a loop literally with like 100,000 items in it. So obviously I can't step through that. But what I'll do is I'll set it up so that, okay, I'll step through 10 items. I'll set it up so that I give it 10 items, step it through. If it's doing the right thing on that, then my leap of faith is if it's doing the right thing for 10, it'll do the right thing for 10,000. Okay, but that's an important step because ideally you should never assume that your code is working. You should always test it because, as the saying goes, when you assume, you make an ass of you and me. Mostly me. Okay, and now, okay, what was this about? This was about. Pardon me?
Capital letters go first.
Yeah, capital letters go for the lexicographic ordering. So again, it's and this it's like they took the line of least resistance because the lexicographic ordering has to do with the way that the characters are encoded. And this goes back to the early days of computing when they the old ASCII character set, where you started with numbers and then capital letters and then small letters. And so if you're sorting that, then what they do is they sort it based upon the number of the character. Remember, each character has a corresponding number. And so lexicographic ordering puts numbers first. I didn't, that's, but then capital letters and then lowercase letters. And so wolf would go before hamster, for example. Okay, so most of you got that, but that's, you see, processing strings is important, and I mean that's something when we start, we're going to spend some time just doing a little bit of string processing and understanding that the case sensitivity and how it sorts these things is something that you need to understand. And then okay, so now here, this was just touching on what does it take to turn an abstract class into a concrete class. And so what you need to do is you need to subclass it and then implement, in this case, I just said just implement as much as necessary as to make it so that it can be instantiated. So in this case, there are two things that you need to do. The first is something that we've talked about before. It has to do with the constructor. See, so you have to explicitly write some constructor that calls super with a string and a value. That, otherwise, again, abstract or not, if you're subclassing a class that has constructor with arguments and no zero argument constructor, then you must do that. That's absolutely necessary. But in terms of making an abstract class concrete, it had one abstract method, and that abstract method must be overridden and implemented concretely. So just to put a point on that, let's stick that in. In fact, here, now notice, I defined an abstract method here, and now I'm getting a red squiggly. Why? Because it says base class is not abstract and does not override abstract method increment value in base class. So I need to, and then NetBeans helps me out. I can just make it abstract. Okay, so now no red squiggly, but I can't instantiate this. As we'll see, let's just to put a point on it. Okay, so here I'm giving it a string. I'm giving it an int as it needs, but it's not letting me do it because it says base class is abstract and cannot be instantiated. Okay, so here's what I can do. I can instantiate it, but then it says it's not abstract and does not override abstract method. So I need to, or I'll do this all by hand here, just to, and that is increment value. Oops. There we go. Okay, so now, all right, so now I still got a red squiggly, but now it's saying cannot be applied to given type, required string int, blah, blah, blah. So again, that's the That's the constructor thing. So I'll just. Well, it's, and you had a choice, so we can. Usually what you want to do is you want to pass it like that. Okay, now I can instantiate the subclass. The constructor's happy because I'm giving it a string and an int. And let's see, did it have a toString? Point is that I can now instantiate it. So that's sort of the end of this. And then, okay, the subclass has a gobbledygoo. All right, so now why is this printing? When you see something like this, you see the toString was not been overridden, so what it did was it went looking for the toString. It went looking for it in the subclass. It didn't find it. It went looking for it in the base class. It couldn't find it, and then it went all the way up to object. And object's toString prints this gobbledygoo. Well, it prints the name of the class, and then just some stuff. Okay, so again, the key here is that if you want to instantiate a base class that is abstract in some way, then you must override it, you must extend it and override explicitly any abstract methods. Now, just one little thing that I hadn't really touched on before, but I do want to point out. Notice that I've defined my variable to be of type base class, but I've instantiated it as a subclass. So is that legal? Well, obviously it is, because it didn't give me a red squiggly. So this is legal because subclass is a base class. So if I define a variable of a particular class, I can instantiate any subclass. Okay, this is when we talk about the collections framework, which we're going to do next, not today, but sort of next. There will, in many cases, what we'll be doing is we'll be defining a variable with either an abstract class or an interface, but then instantiating it with a concrete implementation of that interface or extension of that base class. So there's a reason for that, and that reason we'll talk about when we get there. Okay, so that's right. So that's what was happening there, and so just make sure that you. Well, are any questions about any of this?
I still don't understand the first page, the second page, where we talk about how void can see things that aren't. I'm still not 100% on what void, static, what all those things mean.
Okay.
I just randomly put them in. I know
Yeah.
since variables are private, I do that.
Yeah.
As far as what static does, I know void doesn't require a return statement, but as far as what can see what, who can talk to who, I just play with it till it works.
Yeah. Yeah, and what I'm after here is I want you to not be just playing with it till it works, but to understand how it works. Okay, so and there are several dimensions to this. You mentioned two important ones, like public and private. So that's one dimension that wasn't really being touched on here, but is an important one. So what this what private means is that only that class, that is only an instance of that class, can see what's in that. So this private static to variable can only be seen by a method inside of my class. Okay, so that's the private part. Public, now, if I have a public static, any variable that's public should be static and final, period. That's the only legal or the only acceptable visibility for a variable. So variables should be private, and if they're public, the only acceptable public is static and final. That's the only thing. Now that has to do with visibility inside and outside the class. Visibility inside the class, the difference between instance and static becomes an important one. So put the public and private aside now, because every method inside this class has the potential to see these variables, but only some of them can. In particular, an instance method, that is one that doesn't have the static in front of it, can see all variables inside that class, every single variable. So this new current value and toString for that matter, or the constructor, these can see every single variable, both the two instance variables and the two static variables. That's important for at least one use case that we've seen where, if you remember in the poker player ones, we wanted to assign a unique ID to each player. And the way to do that was we had a static variable that got incremented every time you created one, but then assign that value to the instance ID of that. It's possible I haven't put that into the class code yet. I will do that today. Okay, so instance methods can see instance variables and static variables inside the class. Static methods, though, can only see static variables. Okay, so that's the key point to remember. That static methods can only see static variables. Instance methods can see all variables inside the class, whether they're static or instance. Okay, so remember, instance variables only have, don't have static. That's static variables have static. Okay, does that solidify it for you, hopefully?
Clear some things up. Thanks.
Okay, yeah. And what's the reason that's important is because in a typical program, you will have both static and instance things floating around, and then you'll be in a situation where you want to access something and you can't, and so it's important to understand why and then how to get around that. Okay. So so now the one thing I've alluded to this, but I haven't really been explicit about it yet. But I do want to make sure that you understand this as well. So we talked about in constructors how the first call is super, okay, and so that's sort of the first level of this. But there's a second level, and that is because constructors can be overloaded just like methods. The first call has to be either super or this. Okay, so now what is a call to the, now notice that we've seen this as a variable, but what this is with as a method, what looks like a method, is actually a call to another constructor. So let me show you an example of this. Okay, so all right, let me. Okay, let me do it with base class that I was doing here. Okay, so one of the things you can do is I want to have another constructor. Supposing I want to have another constructor with just the message. Okay? Now I'm getting a red squiggly. You should all know why. Oops, no, public, oops, subclass, sorry. All right, so that was, now you know why. Because it put in a super, and the super required a string and an int. See, can you see that? It says, cannot be applied to given types. Required string int, found no arguments. Why no arguments? Because it put in super with no arguments. So I need to put in super, and it needs a message, at least, so I can take the message that I passed and do that. Although a best practice is actually, I have a constructor here that I want to make sure I call, so I can actually call this, but and it says recursive constructor invocation. So it's okay. Again, another strange message. And now this is the way things are often done, or at least is you set a default value so that if the user is willing to accept the default, then, okay, now the red squiggly went away. Why? Because it put in the default value. And so let's, now, let's debug this and see and walk through this. So, okay, so here we're instantiating it. And I'm calling it now with the new constructor. So if I step into that, notice that it goes here. And then when I step into that, because it called this, it went to the other constructor. And when I step into that, it's going to go to the base class. And then when I step out, it just steps out of the whole thing. And now I have the same output. Okay, so again, this is a very common pattern where you have a master constructor that has all the information, so the user has complete control over what all these values are. And you have other constructors for convenience. So if I'm a user and I'm willing to accept the default, then I only need to give in as much information as I need. And if I want to go even further, oops, pub. And you add a default string, then I can go even further and say, okay, if you're willing to accept the default message and the default value, okay, so now now the user, if the user is willing to accept what the defaults are, then they can. Oh, and I should probably let's oops, that's right. I don't have getters, so I can't really do anything, can I? Okay, but this is a common pattern, and it's a very useful one, because it if you want to give your user maximum flexibility, then they have to instantiate it and pass all the data. On the other hand, if you have a user that's willing to accept the default value of either in part or well, again, you can have another one where the user is willing to accept the default message but customize the value. Okay, so here I have overloaded the constructor, and I have 4 constructors here. Okay, so the user with maximum flexibility can customize it to their heart's content. If they are willing to accept the default value but want to customize the message, they can do it by calling this constructor. If they're willing to accept the default message but want to customize the value, then they can call this constructor. Or if they're willing to accept the default for both of them, then they can just call the zero argument constructor. And so the difference is that this one puts the least burden on the user, but the least flexibility. This puts the most flexibility on the user, but the biggest burden, because they now have to supply all the information. So this is a very common pattern. It's one that I use a lot. And it provides the quote user, the user of this class, that is somebody who is going to instantiate it, it provides them the maximum flexibility in terms of customization and the maximum convenience if they're willing to accept defaults. Okay, so now where we're going next is we're going to look at data structures. Now, the chapter it goes into things like linked lists and what's a queue and things like that. I don't know if have you encountered those things before, linked lists, and you have. So okay, so that should be reviewed. I'm actually less interested in that as I am in what Java has a very robust and rich framework that do all these things for you. In the old days, basically we made you write all these things yourself. So if you wanted a linked list, we made you write a linked list. If you wanted a queue, we had to write a queue. If you wanted a sorted set or a tree or something, you had to write that. With Java, you don't have to do that anymore. But you do need to understand a bit of what's under the hood for that. Unfortunately, the book is very thin on this, and I have not been able to find a reasonable, in my opinion, way of describing this without having you buy like a $100 book or something like that, and that seems excessive. So the main content of this next section is mostly going to be what I talk about in class. Just be warned about that. Okay, because anyway, so that's that, and I will see.